on how to get there. And it's so that we can see how to get algebraically certain things of a quadratic. So you guys have the same thing on your paper. So once again, the first thing we're going to do is graph quadratics in standard form. So on your paper it says quadratics have standard form. And remember that standard form is ax squared plus bx plus c. Correct, everybody? Highest degree to lowest degree, all like terms combined. And then a is what's in front of x squared, b is what's in front of x, and c is our constant. Does everybody remember that? Okay, so when we graph a quadratic that's in standard form, we're going to take these steps. So you can always refer back to your notes. First, you have to make sure the quadratic is in standard form. Once we do that, we'll move on to our second step, find the vertex of the parabola. Now remember, guys, vertex of a quadratic. We have quadratics that are smiley faces and frowny faces. Vertex is the lowest point, the min, or the highest point, max. Correct, everybody? So we can do that by using this equation right here. X is equal to negative b over 2a. Oops, I meant to highlight that in a much lighter color. Let's try that again. So we could, once again, algebraically find the vertex by calculating that equation. That'll give you the x value, because remember, guys, the vertex is an xy point. So that equation will give you the x value of the vertex. And then once you know that x value, you can find the y value by plugging in that x value back into the equation, back into the original equation. So we'll find the vertex xy points using that equation. Once we know the vertex, then our third step will be to find the y-intercept. And that's where it crosses the y-axis, correct? And you'll just do that algebraically by plugging in 0 in for x. That's when x equals 0. Think about it, guys. If this is our y-intercept right here, isn't that when x is 0? Yeah? We plug in 0 into the function, right? It's not over 0 on x, but down, whatever. Everybody understand that? And then your fourth thing is you will use the 1, 3, 5, 7 rule. I don't think I'm going to get into that. It's just too much to remember. After that, I want you to plot at least 3 more points on the graph. Now keep in mind, we did learn how to solve a quadratic by factoring, correct? We factored it down. We set each of those factors equal to 0 to solve, correct? So those could be the 2 points we use to find where it crosses the x-axis. So I think we're going to probably do that too. Does everybody understand? So it's just a little bit different than what we did that first time we were graphing quadratics. Okay, so keep your steps up. Here we go. So problem number 1, the example page. We all have this, correct? On the class notes, everybody can see it. So we're going to graph this. So our first step is to put the quadratic in standard form. And it is in standard form. I'm going to list out what A, B, and C is. Isn't A negative 1? If you don't understand why, make sure you stay today. Wait, can you explain that? Does everybody see why A is negative 1? My B value is negative 2, correct? And my C value is 3. I like to list those out for myself. So our second step is find the vertex of the parabola. So we want to know how low or high this is going. So we're going to use the equation. We're on our second step here. So we're going to use x equals opposite of b, negative b. I always say opposite of b, because that's what negative is. It means times by negative 1. So opposite of b over 2 times a. That's going to be the x value of our vertex. So let's plug that in. What is the opposite of b? Isn't b negative 2? Right? Does everybody see it? So opposite of negative 2 is positive 2. Do you see why? A negative and a negative makes a positive. So I just say opposite of b instead of negative b. So we're going to have a 2 on top, and on bottom we're going to do 2 times a. A is negative 1. So we've got to simplify the top, then simplify the bottom, and then simplify the whole thing. On top we have a 2. On bottom, what's 2 times negative 1? Negative 2. So now we can divide them. What's 2 divided by negative 2? Negative 1. So we know that our vertex x value is at negative 1. So we have negative 1 comma question mark. We didn't know how high up to go. So we do know it's at negative 1, but do you understand that right now we don't know how high up or down to go? So anytime you want to know what your function is at that value, you can just plug in negative 1 back into the function to see how high up or low to go. So let's do that. Let's plug in negative 1. So we're going to plug in negative 1 wherever there's an x. So we have negative of negative 1, plugging in negative 1 squared. Does everybody see where I'm plugging this in? Then we have minus 2 times negative 1. And anytime we plug something in, we use parentheses and then plus 3. So take your calculator and calculate that. Everybody go, ready, set, go. What do we get once you calculate that? You get 4? Did somebody else get 4 so we know we're good? Once again, guys, you need to get graphing calculators here. We have a test coming up, and you're not going to pass the test unless you have a graphing calculator. So we get 4. Did you get 4 too? Perfect. So we have -1, 4. So we're going to go -1 up 4, and we're going to plot our vertex. So that was all just to do the second step. All right, so now one thing to note, don't we know that the vertex, we're going to have our parabola symmetric about the vertex, correct? So just keep in mind, I could, if I wanted, and I'm going to, draw in my axis of symmetry. We know it's going to be symmetric around that point. So let's see what we're looking at here. So our third step is find the y-intercept, where it's crossing the y-axis. I'm going to erase this to give myself some room. So the y-intercept is where it's crossing the y-axis, and that's always when x is equal to 0. So we know that it's going to be when x is equal to 0, so we know it's going to be 0, comma something, correct? So we can plug in 0 into the function. So we're going to have -0 squared minus 2 times 0 plus 3. Think about it, guys. 0 and 0 right here. Aren't those going to be 0? We calculate any 0 squared, 0, right, everybody? And then -2 times 0, 0. So we have 0 plus 0 plus 3. Won't our function be 3? So our y-intercept is 0, comma 3. So over 0, up 1, 2, 3. It's crossing the y-axis at 3. And notice in front there's a negative here. That is, we know that is going to be our frowny face. That's what flips our parabola upside down, which makes sense. If we're coming down like this, it's going to be symmetric over here as well, right? So it's going to be a frowny face. So before we do that, what I want us to do is find our fourth step is to find at least 3 more points. So at this point, you can pull up your graphing calculator. Everybody, pull it up, go to y equals, and then we're going to type in the equation, which is negative. Make sure you don't type in minus. You'll type in negative x squared. So negative x raised to the second. And then you'll do minus 2x and then plus 3. So now you're going to hit graph, and we can look at the graph. Oh, that's cool, but we want the table of values. So remember, you hit second graph. So let's go for some more x. Do you have those pulled up back there that have calculators so I can take this down? So I'm going to plot some more points around the vertex here. So this is at -1. So what's -2? Is that a whole number point? So now I'm just plotting some xy points. What's -2? -2, negative, is it +3? Perfect. Let's plot that. So -2 up 1, 2, 3, which makes sense. It's got to be symmetric from that point. I should have drawn that more round. There we go. And then do we have, what is -3? Is it a whole number? 0. Sweet. So -3, 0. Awesome. So there we go. And so then this one's going to be symmetric, right? Over here. So look, from the axis of symmetry, do you see how we're over 1, 2? We could go over 1, 2. Or you could just say you could go look at your XY chart and say, what's your function at 1? What's your function at 0? We're just plotting points. We get what? Oh, did I not look at it right? This is -1 over 1, 2 over 1, 2. What's our function at 1 is what I meant to say. We get 0. Okay, perfect. So crossing through like that. So what would our solutions have been? X equals -3, correct? And x equals 1 if we would have solved this. Everybody see that? Okay, so it says, what is the axis of symmetry? It's x equals -1, so that's where it was symmetric upon, correct? And then what is the intervals where the function is increasing and decreasing? So remember back to this day, there's kind of a lot to remember, but remember intervals where we're increasing and decreasing, that's coming in from x. So remember it's x value. So aren't we coming in, we're walking uphill on this, correct? So we're coming from negative infinity, we're walking uphill till we hit that x value, which is -1, correct? So do you remember that, doing that? We came in hot from negative infinity, we were increasing till we hit that wall at -1. It gets a parentheses because this point is not increasing or decreasing. And then are we starting to go downhill after that, everybody? So decreasing intervals, the decreasing interval was from -1 to positive infinity. Does everybody see that? Okay. And then domain is, where's your function growing from left to right? Isn't it growing forever left and forever right? Even though it doesn't matter that it's growing down, that's not domain. Left and right, it's growing to negative infinity and positive infinity. And our range is the lowest y value to the highest y value. So isn't this growing downwards to negative infinity? And then it stops at a y value of 4, correct? That's the highest point. So we would say negative infinity up to -4. It did include up to +4, right? I didn't mean to say -4. It grew up from negative infinity up to +4, and it included +4 because it did touch down at 4. Is everybody good? Want to do maybe another one, and then I'll let you practice for a minute. Okay. Here we go. Let's do the example number 2, and then I'll let you try one on your worksheet. Here we go. So it says graph it. So our first step is to make sure it's in standard form. That's done. I'm going to list out A is 1, B is -6, and C is 8. Our second step is find the vertex. We do that using the equation x is equal to -b over 2a. So opposite of b, won't that be +6? So +6 over 2 times 1. So that's +6 over 2, which is 3. So we're going to do 3, question mark. So we know we're over at 3, but we just don't know how high up or down to go. So we can plug that back into our function. So we're doing 3 squared minus 6 times 3 plus 8. So that's, what do we get? You get what? -1, perfect. So we get 3, -1. When you calculate that, you get -1. So we're going over 3, down 1. There's our vertex. So let's write in our axis of symmetry, and let's answer the question. What is the axis of symmetry? Isn't that x is equal to 3? Everybody? Does everybody understand? Because it's over 1, 2, 3. So we have our axis of symmetry at x equals 3. Okay, let's go on. So the next step is it says, our third step is find the y-intercept. So that's when x is equal to 0. So we're going to have 0, something. So we'll plug in 0. So that's 0 squared. Let's think, guys. Let's just think, because this one we can do in our head a lot easier than calculate it in our calculator. What's 0 squared going to be? 0, correct? So we have 0. And then -6 times 0. Won't that be plus 0? Plus 8. So won't it cross at 8? So we're going to plot that y-intercept over 0 up 8. Oh, this graph didn't fit that very good. Okay, so up here somewhere, crossing at 8. And then let's find 2 other points. This time, let's solve it by factoring real quick. How about? So are we doing what multiplies to be a times c? What multiplies, and I'm going to hurry and erase this, give myself some room. I'm going to solve the quadratic by factoring, and then I'm going to use those 2 points, and then I can call it good. So if you solve it, then we know we're finding where it's crossing the x-axis, correct, everybody? So we're going to solve by factoring. So we're looking for what multiplies to be a times c. That's what multiplies to be 8, and adds up to be -6. So we do 1 times 8, 2 times 4, and that's it, correct? So which ones could add up to be -6? 2 and 4, but they both need to be negative. Does -2 times -4 equal +8? Yes. Does -2 plus -4 equal -6? Yes. So we can solve it by factoring. So remember, you drop your n terms down. So you'll drop down x squared You'll drop down positive 8, and then you'll break down your middle term, right? So we'll have our minus 2x, minus 4x. Does everybody remember what I'm doing here? So we fat group the first two terms, group the second two terms. What's the greatest thing in common here? X, guys. I already know how to do this, guys. I have a math degree. I'm good. So do I need to continue, or are you guys good? Do you want me to keep going? Everybody look at me. Do you want me to continue, or are you already understand? Speak. I understand, Ms. Christensen. You don't need to keep going, or actually just keep going. Keep going? Do you guys want me to keep going? What would you like? You're good? Keep going? You're good. Like, you could finish this off. Okay, awesome. So if you guys want me to keep going, I'll keep going. You guys can just start doing your own thing. So we have x minus 2, correct? And then right here, what's in common? A negative. Let's pull out something even greater. 4. Let's pull out negative 4. So then left is divide by negative 4, divide by negative 4. Left is positive x, and then won't that be minus 2? Our safe haven's the same, so we can factor out x minus 2. So then left will be x minus 4. Now can't we solve by setting each of those equal to 0? So we get x equals, if you set that equal to 0 and solve, wouldn't you add 2? Right? So we get x is equal to 2. If we set that equal to 0, we would add 4. So we get x equals 4. So we know it's crossing the x-axis at 2 and 4. So now I can erase that so I can continue graphing it. I don't have very much room to write up here. Okay, so our quadratic was crossing at positive 2 and positive 4. So positive 2 and positive 4. And our y-intercept is up there, so now we can graph this. And our axis of symmetry was right there. Okay, let's answer the questions. What's the axis of symmetry? It's x equals 3. We've already answered that. What are the intervals where the function's increasing and decreasing? So isn't it decreasing first? Picture yourself stepping on it from left to right. Remember, we look with our eyes from left to right. When we be sliding downhill. So we're decreasing first. I'm going to put a D so that I know that I'm talking decreasing. So we're decreasing. We're coming in from negative infinity till we hit the wall at what x value? 3. So we're decreasing from negative infinity up to 3. And then after 3, we start increasing because we're walking uphill, and then we keep walking uphill till we go to positive infinity. So then we're increasing from 3 to positive infinity. Does everybody understand? It's never how low or how high up. It's just the x value. Domain. Where's my function growing? It's this way and this way. Isn't it? It doesn't matter that it's growing up. That's not domain. It's left and right. Isn't it growing to negative infinity and positive infinity? Okay. Our range is the lowest y value to the highest y value. So what's my lowest y value on the function? Right, it's the y value, so negative 1. And then it grows upward forever to positive infinity. And then negative 1 gets a bracket because it includes negative 1. Everybody feeling good? You are ready to practice on your own? Okay. So what I want you to do is do problems on your sheet. So go to your thing, and you're going to do, let me look at it. Do 1, 2, 3, and 4 on the front. Okay, so now we're going to graph, I guess I better turn off the light. Okay, so we'll graph now. If you go back to the teacher class note worksheet, whatever it says, it gives you the steps. So we're going to graph quadratics in factored form, meaning it's not in standard form. Ax squared plus bx plus c is already factored for you. So it'll look like y is equal to x, for example, x minus 2 times x plus 3. Does everybody see the difference between that and standard form? That one's already factored, right? So these ones are actually a lot easier to graph because what we'll do is first you'll find the zeros and plot those, because can't you just set each of those equal to 0 and solve? So you'll first find the zeros, so you'll graph them, and then so we would plot a point at x equals 2 because we'd set that equal to 0 and solve. We would get x is equal to negative 3. And then we would plot those points. And then our second step is find the vertex. Now the vertex is always going to be halfway between your zeros. So everybody look right here. Do you see how this is solution -1 and 2? My vertex is always going to be halfway between those. Oops, I didn't draw that very good. Halfway between those two zeros. So what you'll do is you'll take the distance between those, which notice from -1 to 2 is a total of 1, 2, 3 units, correct? Everybody? You see what I'm saying? So 3 divided by 2. You'll take the total of those distance and you'll divide it by the total distance of those x values divided by 2. Isn't that 1.5? Everybody, 3 divided by 2. If you don't know that, put it in your calculator. So that's over, oh, no. What is 3 divided by 2? 0.75, I mean. What is it? Wait, what am I not thinking right now here? Isn't that a total of 3 units? 1, 2, 3. Oh, yeah, that makes sense. So it is 1.5, but that's 1.5 from this 0. Does everybody see that? So we're going over 1.5. You get what I'm saying? So halfway between the, sorry, I usually don't ever graph these times. So we're going over from this 0 over 1.5. Ding, 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 ding. So then you will say, okay, what? I didn't even think about that very much, did I? So it says 1. Because here's what I think is going to confuse you guys, and it confused me for a minute. We can't plug in 1.5 because that's not 1.5, correct? That is 1.5 from here, but look, here's 0. Isn't that only over a half? You get what I'm saying? So just, you'll have to start at 0 and say, how far over did I go? Well, from here I went over 1.5, so I went over a half. So our x value is actually for a vertex 1/2 or 0.5. So we've got to plug in 0.5 in, otherwise we're going to be calculating something at 1.5. Does that make sense, everybody? So now we'll plug in 0.5 into our function back in here. So we can just type it into our calculator, and then we'll have the vertex, how far down to go. And then third, find the y-intercept, so we know where it's crossing the y-axis. And then plot at least 3 more points. So we'll just do some examples and it will make more sense. Here we go. Example number 1. So we have x minus 3 and then x plus 5 here. So here we go, guys. We've got this. So we know it's in factor form. So we know x is equal to 3. Wouldn't we set that equal to 0 and solve? Can I skip that step, or does that confuse people? You get why I get x equals 3, everybody? Yeah? And then we get x is equal to -5, right? So that's what's crossing the x-axis. X is equal to 3 and x is equal to -5. So let's count the distance. 1, 2, 3, 4, 5, 6, 7, 8. So what's 8 divided by 2? 4. So that's 4 units from one of the zeros. That's where our vertex is going to be. So start at a 0, go over 1, 2, 3, 4. Right there is halfway between. I'm going to draw in my axis of symmetry. So we need to know how far down to go, right? We know it's on that x value, so we know x is equal to -1 is on the vertex. So we're going to do -1 comma something. So let's plug in -1. So parentheses, -1 minus 3, close your parentheses, and then -1 plus 5. Does everybody see how I just typed in -1 wherever there's an S? So that would be -4, and you could literally just type that into your calculator as long as you use parentheses, but a lot of you didn't bring your graphing calculators. So we have -4 times 4, correct? So we get -16. So it's not going to fit on here. I didn't give myself a very good XY chart. So we're at -1, -16. Did you type that into your calculator and get what I got? Okay. So we're going -1 down to clear down to -16, clear down there somewhere. And then from there we'll graph the y-intercept, which is going to be when x is 0. So the y-intercept is when x is 0. So we're going to have 0 minus 3 times 0 plus 5. So we get -3 times 5, which is -15. So our y-intercept is at 0, -15, so I still can't graph it, but it looks something like that. So then if you have 2 zeros and your vertex on the y-intercept, that's plenty to draw an accurate graph, I think. So my graph just wasn't very good. My XY chart I put as an example. So I apologize. It's so hard to get ones that are 20s though. It's just hard to get them to fit, and then they get looking too small and you can't even read them. Anyways, questions on that? Not too bad. Maybe one more, this one. So it says y is equal to x times x plus 4. So we would set each of those equal to 0. So we say x equals 0, correct? And then we have x plus 4 equals 0. We'll solve. So subtract 4. So we get x is equal to 0 and x is equal to -4. That's where it's crossing the x-axis, at 0 and at -4. So now we know that the vertex is halfway between those. Let's figure out how many units that is. Isn't that 1, 2, 3, 4 units? 4 divided by 2, because that's halfway between, is 2. So from one of the zeros, we're going over 1, 2. So our axis of symmetry is right here. So we know our axis of symmetry is at x equals -2. So we know we're going to have -2 comma something. We'll plug in -2 into our function. So -2 times -2 plus 4. So that's -2 times 2, which is 4, -4. So we get -2, -4 is our vertex. So I'm going back 2, down 4. Is everybody feeling good? Now our last step, and I don't care, that's plenty of points. If you graph a y-intercept, we're good. So y-intercept is when x is equal to 0. So we're going to have 0 times 0 plus 4. So won't that be 0 times 4, guys? Which is 0. So that solution is our y-intercept as well. Interesting. So we'll draw in our parabola, and it's symmetric around that. Now, once again, if we wanted, we could always just plot a bunch of points by plugging that into our y equals in our graphing calculator and plot a bunch of points. If you're drawing a correct graph, you really should be getting points for it. Is everybody good with that? Okay. If you're feeling confident with those, I'll just let you practice, and then we'll call it good for the day. So what you're going to do is actually go to the worksheet. Let's do how there was a blank page or like a single page. Let's just practice those ones on that, and then we'll call it good. So if you can hurry and finish up those ones, and I think you understand the lesson for today, we'll call it good.